Good evening, ladies and gentlemen. Here we go. We're going to be looking at how to verify identities. Now, what is an identity? Well, an identity is a mathematical statement, a mathematical equality that's true for every single possible value of x. And what you'll oftentimes see is a triple-decker equal sign, and that is defining that this statement is true for every value of x. A lot of times identities are simplified down to just being a traditional equal sign. Either way to write it is correct, but just know that this, the triple-decker, means true for all values of x. It's a stronger statement than just your traditional equals. So how do we verify that something is an identity? Well, it's an algebraic process where we start with one side of the equality statement and work with that and turn it into the other side. This is not a work with the left side, work with the right side, and try and meet in the middle sort of thing. It's a build a brick wall down through the equal sign, and you're not allowed to cross over that brick wall. You are basically ignoring that side, and you're making this side, or conversely the other side, look like what we're ignoring. This is our end goal. Our end goal is to take usually the more complicated side, and turn it into the easy side. I'm not going to write anything on the right side of this line. I'm going to work with the complicated side. So here we go. What skills can I use here? Well, 2 natural log x, that's going to be natural log of x squared. It's a property of logarithms. And this is very important that you show step by step. You can't just say, well, I did some stuff and I ended up over here. You have to give a convincing argument for how you get there. What process do you go through? So you must show every step that you do. So another property of logs becomes natural log of 3x squared. And then e to the natural log of 3x squared, e to the natural log, those cancel each other out. That's a cancellation property. And we're left with 3x squared. We are done. The two sides agree. We have just verified that this original statement is an equality. Now, what does that mean for us? Well, what it means is that if I have this big thing in an equation, in a function, in an expression, I now know that I can replace it with that thing without doing any other work. So we're going to use this idea quite a bit once we get to dealing with trigonometry later on down the road, but for now we're going to practice taking one side and making it turn into the other.